Good morning, everybody. It's me, Prajapati Simharajala. So, going to teach, okay, the difficult topics of 10th class lessons, right? So, my intention to create these videos is that I have a passion to provide my best to you all, right? So now I have been preparing for a government job, but I have passion to teach. That's why I don't want to leave this passion to teach. So that's why I'm creating the videos in the form of lessons. Okay, so in these lessons, right? So I'm focusing on only difficult topics, and I hope this will be very helpful to you people. Why I'm focusing only on difficult topics? It means that it has a reason. So why? Because we are having very less time before the examinations. The examinations are going to start from 19th on. So that's why I have a very limited. We have very limited time. That's why I'm focusing only difficult topics. Okay. So please utilize. I hope that you all will utilize this, right? And with that interest, I'm doing these videos. Okay. And please, I request you all that after watching video, don't forget to subscribe. Okay. And after watching the video, if you are having any doubt, you can comment it in the YouTube channel itself, and you can message me, or you can call and ask me over my number, right? And our YouTube channel is Simharajala Prajapati. Okay, so daily you can visit that YouTube channel, and you can watch the videos, and you can have the doubt clarifications by calling me or messaging me or sending messages personally also. Okay, so right, today I'm going to discuss about electric current. From that, so I feel that most of the students will face the problem in circuit problems. Okay, so what are the mistakes the students may do, right? See, before going to solve the circuit problems, so which is depending on Kirchhoff's loop law, so you should have the knowledge of electric potential, potential difference, conventional direction of current, sign convention for the potential difference across the different components in a circuit, and you should have the clear idea of Kirchhoff's loop law, right? So first of all, let us see what is potential, right? So what is electric potential? So students, right now this is the first video, and I'm not having all proper facilities, but later I will come up with all the facilities at webcam and all those. So right now I'm not able to show my face to the camera throughout the video. Okay, so sorry for the inconvenience, and now I'm going to show on paper. So you see here, you should have the knowledge of potential, electric potential, potential difference. What is potential difference, right? Conventional direction of current, sign convention, Kirchhoff's loop law. So first of all, let us discuss about potential. Electric potential. So generally, see, to get the knowledge of anything, first of all, when we are going to learn any definition, so first of all we should know the word to word meaning. So here, electric potential, what is the general meaning of potential actually? So potential means it is energy, it refers energy. Okay, so that is the actual meaning of potential, right? Potential, so energy, so potential means energy. So are we to do any work, we need energy, isn't it? Okay, so here potential, electric potential. So regarding, before going to discuss this electric potential, who is doing work? Okay, so what are the work has done by somebody, right? All of you remember that if we do any work, whatever the work we will do on a body, that work will be resulting as energy in that body. For example, if you lift an object from ground, that gains potential energy. You are doing work, but the body is gaining potential energy, right? So similarly, in these circuits, electric circuits also, there is something which is doing work. So what is that? Which is nothing but source of energy, which is called battery, right? So the battery initially pushes the electrons. Okay, so now see here, not only battery, so generally if we do any work, right, so suppose that we are bringing a charge, a unit positive charge q from infinity into an electric field. Okay, let us suppose the charge q is at infinity, right? So this charge you are bringing into the field of another charge. So the work done, right, so the work done on this unit positive charge, the work done on this unit positive charge is called as electric potential, right? So work done on unit positive charge to bring from infinity to a point in the electric field. Okay, so here is some electric field which is around another charge, either it is positive or negative, whatever it is, but we are bringing a unit positive charge from infinity to a point into the electric field. Okay, so this work done is called as electric potential, right? For example, right, so this is unit positive charge, this is unit positive charge, and this is electric field. Okay, around any charge, like either it is positive or negative, whatever it is, right? So this is called electric potential. So you remember that work done on a unit positive charge to bring it from infinity to a point in the electric field is called as electric potential. Now what is mean by potential difference? Next thing is that potential difference. Suppose that there is a charge q, unit positive charge q, in an electric field at point A, right? So this charge is moved from point A to B in the electric field. This charge is moved from point A to B. Okay, so now initially this charge is in the electric field and this charge is moved from point A to B. So who is pushing this charge? So there is electric field either by battery or induced electric field in the conductor, whatever it is. Okay, now so there is a need, so electric field is needed, so electric field is doing some work on this charge. Okay, right, so the work done by the electric field to move a unit positive charge from one point to another point through a distance L, whatever it is, or D. Okay, so it is the work done. So potential difference means it is the work done by electric field on a unit positive charge from one point to another point. Here the points are A to B. Okay, so why are you saying this potential difference? Initially this unit positive charge has brought from infinity into electric field. Now it is in electric field. So when you have done some work on this unit positive charge to bring from infinity to electric field, this charge has got energy. Previously I have told that whatever the work we do on something, that work will be resulting as energy in that body. Now we are doing work, okay, to bring this unit positive charge from infinity to a point A, let us suppose here, in the electric field. So we have done work on this unit positive charge, so it got energy, means it has potential, it got potential. Now it is at A with some potential, still we are working to move it from point A to B. Further it is gaining energy, means its potential has increased. It may or may not be increased, right? It may be sometimes decrease also, that depends. Okay, that depends on the situation. Now here in this case we have brought this from infinity by doing that work. It got some potential, okay, when it is at point A. Now we are moving this charge, unit positive charge, from point A to B. Still it is gaining the energy. So here it will have some more energy. Here the energy will be high, here the energy will be low. So there is a difference in the energy, there is a difference in the potential between these 2 points. Okay, that's why we call that, okay, the work done, whatever the work done we have done, whatever the work done by electric field to move a unit positive charge from point A to B is called as potential difference. Okay, so the charge Q will not have same potential at point A and B. At point A its potential is different compared to the potential at point B. So if you take the difference, that gives potential difference. That potential difference is nothing but work done by electric field to move it, okay, from point A to B. So we are saying that work done per unit charge. How can you express this mathematically? How can you express this mathematically? See here, let us see a simple mathematical expression. I'll say that 20%. How can you express this in the form of fraction? So you can express it as 20 per means you should use divided by symbol. Cent means century means how much? 100. So 20%. So here I am saying that work done, generally work done will be denoted by W. Work done per means divided by unit positive charge. This is unit positive charge. So work done per unit positive charge is called as potential difference. Potential difference. Okay, so work done per unit charge to move it from one point to another point in an electric field is called as potential difference. So potential difference or potential, whatever it is, electric potential V, potential difference also V. The electric potential or potential difference will be denoted by a letter V, and you can write it as V equals to W by Q. Okay, so W by Q. So this is the formula for potential difference. Okay, work done per unit charge, unit positive charge. Work done per unit positive charge is called as potential difference. So what are the units for potential difference? What are the units for potential difference? So units for potential difference are, see, the unit for work is joule and charge coulomb, joule per coulomb. This is nothing but volt. This is nothing but volt. This potential difference is also called as voltage. So the unit for potential difference or voltage is joule per coulomb, which is nothing but volt. So 1 volt equal to 1 joule per 1 coulomb. Means if an electric field is doing 1 joule of work to move the 1 coulomb charge from one point to another point is called as 1 volt. So 1 joule by 1 coulomb equal to 1 volt, and the unit for potential difference is volts. Okay, so for this I am going up to this much brief only. Why? Because we have to discuss circuit problems also. Okay, so you remember now, electric potential means to bring a unit positive charge from infinity to a point in the electric field. Okay, already we have brought that unit positive charge to a point A in the electric field. It is in the electric field now. This is happening in the electric field. Okay, so now electric field is further doing work to move it from point A to B. So it has some potential. After doing some more work, it got some more potential. So there is a difference between potential between these 2 points. That's why we are calling it as potential difference. Okay, right. Now the third one is, what is the conventional direction of current? So the conventional direction of current can be explained by the Drude and Lorentz equation, that is I equal to NQ AVD. Students, please remember, when you are writing a formula, immediately after remembering that formula, you should remember the description of each and every term in that formula. So where I is current, Q is charge, either it may be negative or positive, whatever it is. Okay, so and A is area of cross section of conductor, area of cross section of conductor, cross section of conductor. And Vd is drift speed or drift velocity, drift speed. Okay, so how can you know the direction of current? So the direction of current depends on the energy carriers. So here the energy carriers or charges. The charge may be either positive or negative. Okay, right? If you take, let us suppose the charge is positive. The charge is positive. So you substitute this positive charge in this equation, N plus Q into A into Vd. So the direction of current will not depend on number of charges N and area of cross section A. It will depend on the charge, type of charge Q, and the sign convention for the speed of the charges. Okay, so you are getting here I equal to plus NQAVD. Okay, so when you are taken, if you take original equation I equal to NQAVD, both side, left side and right side, both are having same symbol, that is same sign, that is plus. Both sides you are having plus here and here. But when you are taking a positive charge plus Q, then also you are getting both sides plus symbol. Means the charges Q and the current I both are in same direction. The charge Q and current direction I both are in same direction. Means in what direction charges are moving, current is also flowing in that direction. When the charges are positive. Let us suppose if the charges are negative. If the charges are negative, right? Now you substitute this minus Q in the Drude and Lorentz equation. I equals to N minus Q A Vd. You will get here I equals to minus NQ A Vd. See, you are getting opposite symbol. I is positive, but this total quantity you are getting negative. Means the direction of current I and the direction of motion of charge Q both are opposite to each other. So if this is the direction of charges, negative charges, and the direction of current will be opposite to it. Direction of current is opposite. Okay, so you remember that when the energy carriers, which is nothing but when the charges are negative, when there are negative charges flowing in a circuit, the direction of current, when there are negative charges flowing in a circuit, the direction of current will be opposite to the motion of charges. Okay, so generally in electric circuits almost we'll use the metals as the conductors. So in every metal, the charges which are responsible for the current are negative charges, which are nothing but electrons. So in conductors, the direction of current is taken as it is opposite to the motion of charges. It is opposite to the motion of electrons because the charges are here electrons, right? So this is the direction of current we can understand from Drew and Lorentz equation. Okay, right? And the next thing is so sign convention. Now we have to write the sign convention for the potential difference. Okay, so according to Ohm's law, see here, we have to write the sign convention for the potential difference across different components in a circuit. The different components, it may be a resistor, it may be a bulb, it may be battery, or whatever it is. Whatever the things are there in an electric circuit. See here, you have electric circuit at your home, right? You have mains, you have fuse, you have bulbs, fans, refrigerator, television, so many are there. So all these main, fuse, bulb, refrigerator, fan, all these are electrical components, right? Now potential difference, okay, or you can say it as potential drop. So why there will be a potential drop across each and every component in the electric circuit? The reason is that, now let us take a simple circuit. Okay, so this is, see here, you have a resistor, right? Now this is battery and this is switch, right? So you have to measure the potential difference across the resistor. Generally potential difference is measured by a device which is called voltmeter. This is voltmeter. Always voltmeter should be connected in parallel combination. So what is mean parallel combination? If the positive of the voltmeter is connected to positive terminal of battery and negative terminal of the voltmeter is connected to negative terminal of the battery, means positive to positive and negative to negative. So that is called parallel combination. Okay, right? So this is the resistance, or let us suppose the direction of the current is flowing in the circuit is away from the positive terminal of battery. You remember in any circuit, if there is a power supply, so the direction of current will be away from the positive terminal of battery. Remember it. Okay, how it is, let us discuss that also. Okay, see here, why the direction of current I is taken as away from positive terminal of battery when the conductors are metals. These are all wires, connecting wires, right? These are all metals. I told in metals the direction of current is opposite to the motion of electrons, right? So when you connect the battery here, right, each conductor, these all wires are nothing but conductors. Each conductor will have free electrons in it. Okay, so these electrons, if there is an electron inside the conductor, it is having negative charge and this is having positive charge. Okay, this is negative terminal of battery and this is electron with negative charge. So negative and negative will repel, like charges will repel and unlike charges will attract. So these electrons in the conductor will repel and move throughout this circuit in a closed path. Okay, so electrons are moving in this way. Electrons are moving what? Anti-clockwise direction. Electrons are moving in the anti-clockwise direction. But the current direction should be opposite. This should be the direction of current. And this should be the direction of motion of electrons. So opposite to it. So that's why the direction of current in a circuit will be away from the positive terminal of the battery. Away from the positive terminal of battery. Okay, now so there is a battery of EMF. Okay, let us suppose this is V, right? And because of this battery, so initially this is pushing the electrons, this battery is pushing the electrons in the conductor, so electrons are moving. Electrons have some energy, it got some energy here, right? When initially the electrons are repelled, okay, so this battery is applied some force on it, means it has done some work on this electron. This electron got some energy, which is nothing but potential, right? It has some energy and it is moving here here it's coming like this. This electron is coming here with some energy. Here it has some energy. Let us suppose, means energy means it is a potential. It has some potential. Let us suppose V. Okay, right? Now let us take a point A and here a point B. So the electron is coming from here and it is reaching this point A with some potential V. Let us suppose, let it be VA. Now when it has passed through it, what is this? This is the resistance. This is resistance. So resistance means it which opposes the flow of electrons through it. This resistance is opposing the electrons to flow through it. The electrons are having some energy, but this resistor is applying opposite force on these electrons. There is obstruction to the flow of electrons in this resistance. Okay, means at each and every collision, this obstruction is nothing but these electrons. When the electrons are moving in a conductor, they will collide with the lattice ions in the conductor. So at each and every collision, they will lose the energy. So initially they have some energy VA. Let us suppose they have some potential VA. They are entering into resistor. After crossing this, means they have undergone many collisions inside the resistor. Because of those collisions, the electron has lost some energy and it is coming out of this resistor with some energy. Let it be electric potential, let it be V at this point. So generally the energy at point A, energy of the electrons at point A will be higher than the energy of electrons at B. So let us suppose this point, it is at high potential. This point A is at high potential and this point B is at low potential, because when the electrons are reaching here, they initially gained energy from battery. They are coming with electric potential VA, which is nothing but energy, and entering into it. After passing through this, they are losing some energy. It's nothing but there is a drop of potential in this resistor. They have lost energy, right? Means there is a potential drop. After that potential drop, whatever the potential is there, that let it be VB. Okay, right? Now you know that here some energy VA loss. Okay, energy decreased. It is less. So VA is greater than VB, right? So if you take the difference, either VA minus VB or VB minus VA, which is nothing, which gives potential difference V, which gives potential difference V, either this or this. Whatever you can do to calculate the difference, you can do initial minus final or final minus initial, whatever. Okay, but the thing is, whatever the difference, whatever the subtraction you are following, either initial minus final or final minus initial, whatever you are doing, that should be followed. The same should be followed throughout the circuit for each and every component except battery. For each and every component, either it is battery or resistor, whatever it is. So in your textbook, it is given that you see here sign convention. So while we are following a sign convention for battery, potential difference across the battery and potential difference across the resistor. Okay, so how they are taken, you see here, this is positive terminal of battery, this is positive terminal of battery, and this is negative terminal of battery. So this is the direction of person while he is traversing the circuit. So in this way a person is moving. First he is reaching positive terminal and next he is reaching negative terminal. Initially positive, finally negative. So potential difference is becoming as negative. It means what? When you get a negative quantity after doing subtraction, all of you see here. See, if you do 2 minus 3, you will get minus 1. If you do 3 minus 2, you will get plus 1. Means low minus high, you are getting negative. High minus low, you are getting positive, isn't it? Low value minus high value, you will get negative. high value minus low value, you will get positive. Okay. So now, whatever the sign convention given in your textbook, all of you see here, I am drawing that also. So we have to follow the sign convention. This is about sign convention, right? We are discussing about sign convention. So you see here battery, right? This is the positive terminal and this is the negative terminal. So in a circuit, you are traversing the circuit in a direction that while you are traversing the circuit, first you are reaching positive terminal and later you are reaching negative terminal. But if this is the direction of traversal of a person in the circuit, so what you are getting, the potential difference, you are getting negative. Negative means it should be high minus low or low minus high. It should be low minus high, means the positive terminal of the battery is at low potential and the negative terminal of the battery is at high potential. So if you do low minus high, you will get negative, right? You see here, if you are traversing the circuit, during the traversal, if you are initially reaching the negative terminal and finally you are reaching the positive terminal. So negative is high potential and positive terminal is low potential. So you do potential difference. I want to do potential difference, high minus low. Okay, you will get positive. So what they are doing here, always initial minus final they are doing. Okay, right? Initial minus final. See, if this is low, right? So the potential of the battery, right? The potential of this positive terminal, if it is, let it be VA, and the potential of the negative terminal, let it be VB. So this negative, how they are getting? This negative equal to, it's nothing but VA minus VB they are doing. They will get negative. And here also, if initial one is what? VA. Okay, let us suppose. And this is, let it be VB. So they are doing high is what? VA minus VB, low. You are getting positive. Why? Because high minus low is positive. High minus low is positive. So this is the sign convention to write the potential difference of a battery. So while we are writing the potential sign convention for the potential difference of battery, you remember the positive terminal of the battery is at low potential, L. The negative terminal of the battery is at high potential, H. Okay, if you take the potentials of the initial and final points as VA and VB, you have to do VA minus V. Initial, always they are subtracting initial value minus final. You remember this you have to follow throughout the circuit. Initial minus final, you have to follow throughout the circuit, either it is for battery or resistor or whatever it is. Okay, so this is the sign convention how to write for the potential difference of a battery. Okay, the potential difference of the battery is also called as EMF. Okay, and next, resistor. Let us see the resistor. So to write the potential drop or potential difference across the resistor, we have to take the direction of current as a reference. We have to take the direction of current. Our reference direction is current. We have to look at, in the case of battery, we have looked at terminals. Okay, high and low. Here also high and low we have to use, but which direction will be taken as reference? The direction of current will in the circuit will be taken as reference. Okay, so we are traversing in the circuit. While we are traversing the circuit, if we are moving in the direction of current, if we are moving in the direction, this is V, this is V, this is V. If we are moving in the direction of current, now we are moving in the direction of current means what will be the direction of flow of electrons? Opposite. Electrons are moving like this. This is the direction of flow of electrons. Okay, so we are moving in the direction of current. but the electrons are moving opposite to us. I told direction of current is opposite to the flow of electrons. This is the direction of current. We are moving in the direction of current, but the electrons are moving opposite to us. Isn't it? So when the electrons are moving opposite to us, initially they are coming with some energy, let it be point A and let it be point B. This point A, at this point A, the electrons are having high energy. Okay. And at point B, the electrons are having low energy. If VA is the potential at point A and VB is the potential at point B, we have to take the difference. So to calculate the difference, we have to do initial minus. We have to calculate the difference. We have to do initial minus final. Initial is VA, so VA minus final VB, which is nothing but high minus low. What you'll get? You'll get positive. Means you remember that when we are moving in a circuit in the direction of current, the potential difference across the component, here the component is the resistor.